Hi, my name is Philippe Longchamps and I was asked to make a short video about what we're doing right now in Sweden with 4DFrame. So, like every year, we are now participating in the contest Enlightening Imagination that is organized nationally by Mariana Bach and Nordic 4DFrame. And this year's theme is the Eco Fun Park. The regional contest is organized by Vattenhallen Science Center in Lund, and our school, Bilingual Montessori School of Lund, has been participating in that contest for the last 4 years. We're going to look at some footage from the regional qualification round, where the students from BMSL are trying to develop a creative way of building some fun attractions for a theme park while using as little energy as possible, or to use renewable kinds of energy. This way, they are encouraged to build prototypes where they are developing their creativity by experimenting with the material.
Wheel spins so the thing locks in place, and then people can sit in there without flying out, and then you can just remove it.
You will see that the 7th graders are beginners, and by creating new devices, they are learning through mistakes. And what is interesting to observe in these circumstances, like you can see here, is that some students come up with new ideas because they are making mistakes. And of course, this is something that we have discussed thoroughly in our first article in Borderless Connectivity, when Charles Graham and I wrote about this creative process where students use 4DFrame material and make discoveries by accident. And this year is no exception to the rule. We will see some footage here where students are building their prototypes. And in the Swedish curriculum, one thing that is very important in technology, there is one knowledge requirement that is essential. It is a problem-solving requirement. So we expect the students to encounter problems and we evaluate them on their skills on how to solve them. Like I said before, this contest, Enlightening Imagination, is a 4DFrame contest throughout Sweden. The national contest is organized by Nordic 4DFrame and Mariana Bach. And in our region here in southern Sweden, the contest is organized by Vattenhallen Science Center and our friend Stefan Zamudio, which provide the material to our school, and they decide a theme, and our students are competing in a creative way to try to find ecological solution to build a fun amusement park. Last year's challenge was called the Wind Power Challenge, and this year as well we are encouraging the students to try to develop devices that can be powered by the wind or by water. Even some students are exploring the conceptualization of ideas where their prototypes are powered by some geothermic forces. The idea of using renewable sources of energy to create new devices or build prototypes is something that we want to encourage because we have to aim at the sustainability goals of the United Nations 2030. This year's mission was to create some type of carousel for an amusement park that is powered by different types of energy. One thing that is very important is that each prototype developed by these teams of 2 have to have 2 interacting moving parts. Each team receives exactly the same starting kit. By using an electric fan to power some of their devices, students are also becoming aware of some principles in physics. This way, they understand that designing a very good wind catcher from the side or from the front has to respect some basic properties that are found in basic physics. What's great with 4DFrame material is that 4DFrame respects the geometrical principles of mathematics as well, So students understand very early on that building structures while using equilateral triangles makes everything more stable. This math and science creative teaching tool is an excellent way to promote creativity, because like I said, it is a way to incorporate different subjects, in this case physics, mathematics, engineering, technology, but also the question of sustainability, and of course there's no creativity without fun. So the students remember what they're doing because they're first of all doing something with their hands, and second of all they are encouraged to think outside the box. Each team is provided with a pair of scissors, a pencil, and all the material necessary to build their prototypes. Of course, since we provide scissors, you understand that the students are also allowed to cut in the 4DFrame material. Each team receives a paper like this where they write their names, their team name, the team number, also the name of the construction with the instructions in their native language, Swedish. And on the other side, they are talking about the technical and scientific properties of their prototype, and they have, of course, to write a sketch of their construction. The jury takes this into consideration in their evaluation as well. Like I mentioned before, first of all, the students who understand mathematical principles to create stability often use equilateral triangles to create sturdy structures. So by building with 4DFrame, there is also the problem of friction. Once you have moving parts, the students understand that using these parts here, they will always work better when they are intertwined like this. But most of them, at the beginning, they tend to put them like this, and it creates a bit of tension like that. This can make a difference between the first place and the last place. These small details, when the students are learning to build their prototypes creatively, using these parts, need to learn to think about friction as well. So I demonstrate again, by making them intertwined like this, they create much less friction and the angles stay much more stable than if they put them on the side like this. Once the students learn to make equilateral triangles and use the intertwined system here, almost no friction is found, and it makes their prototypes much easier to turn. They can easily catch wind, and this way, once they're put in front of an electric fan, they turn freely because the friction is minimal, and in this case it's easier to add a second cogwheel that will interact with this one with an XY axis. Then they can power a carousel or any type of device. It can be a drill or anything that rotates in the other direction in a simple way. So by conceptualizing this, they're learning basic mechanical principles. And remember, triangles make everything more stable. The different teams who try to explore this wind power source, the electric fan, in this case, in this contest, also learn that there is an optimal angle in the different windmill they are building. So by having about 30-degree angle in their windmill, like this, they understand that this, after many different types of tests, will be the most efficient one when the wind is facing the construction. Another aspect that the students often discover on their own by accident is that by creating equilateral triangles, the 60-degree angle gives very sturdy construction. But if they want to create something even more stable, they will understand that if they build their equilateral triangle upside down, it will create even less friction. So Enlightening Imagination, this regional contest that we've started here at Bilingual Montessori School of Lund, will hopefully bring some of our students to the national finals, where they're going to have to record a video about their invention, and the 5 lucky teams from Sweden will hopefully represent Sweden at the next IMSCC in South Korea, either online like we did last year because of the corona pandemic, or hopefully in Seoul at the Science Center for the IMSCC finals. My name is Philippe Longchamps. Thank you very much and 감사합니다.